Hello everyone, I'm Mr. Sheehan. For those of you that don't know me, I teach Algebra 1 at LHS Harmon. I'm kicking off our third week of digital learning, and I just want to tell you that on behalf of myself and your teachers, we are so happy that you guys are diving into this and learning how to do this with us. In the coming weeks, you'll have an opportunity to visit with your teachers just like this via WebEx. You'll also see some of your classmates on there, so I hope you're excited about that. I know we are. Reach out to your teachers during office hours or anytime via email. We're here to help, so let us know what you need, anything and everything. Let me switch over to the iPad and walk you through this week's lesson on quadratics. All right, everyone, so I wanted to start by just showing you what it'll look like on Canvas. Your view is going to look a little different. I'm on the teacher view, but I just want to show you. It'll be under modules under their Algebra 1 AB section. And so see that you kind of have 6 things here on the left for next week, week of 13 through 17. You'll have your lesson plan, which just kind of is more for your parents and for us teachers, but it does show an overview of everything that's happening this week. You've got the notes, which I'm going to work through here in just a minute, and then the video, when this video is posted, it'll be here. Other videos from your teachers might be available here under this page. And here's what you need to focus on is the at-home learning experiences and activities. So this week we're asking you guys to do a total of 4 things. First, you want you to watch the video, this video here, so you're already doing that. Next, there are 4 practice problems that you can see right here, number 1, number 2, 3, and 4. And then for the third thing, we want you guys to be on IXL. Some of us have used it, some of us haven't. Look for an email from your teacher explaining more details on that, but for those of you that are familiar with it, it's just a website where you're going to go do some practice problems, and you want to get a score above 80%. Your teacher may change that number, raise it or lower it, but it's pretty easy and really self-explanatory. Again, those of you that use IXL, you guys know that that's a pretty easy program to use. And then the last thing is going to be a quick 10-question quiz, number 6 here. You'll have 3 attempts to take it, and only your highest score will be kept. So pretty good deal with that. And those assignments here are here on the Canvas. You'll upload a screenshot of your SMART score from IXL here, and you'll take the quiz on Canvas as well, 10 questions. So let me kick over to the notes. And this week we're talking about quadratics. Now some of us may have already covered this and some of us not. That's all right. Wherever you are, either we're reviewing it or we're looking at it for the first time. So let me start with a quadratic is a parabola. And a parabola is this shape. It's a U shape. It might be like this. It might open up or it might actually open down, upside down, kind of like that. It's going to be one of those 2 situations. Let me write the word parabola here. That's what that is. A U shape is a parabola. So basically, what we've worked with up until this point are linear functions. Those create lines. Linear is pretty straightforward. Linear means it makes a line. And parabolas make a U shape. That's quadratic functions make parabolas. So the vertex here, and I'm going to color code, is the lowest or highest point. In this example, the lowest point is down here at 0, -4. You have 2 roots, usually. Sometimes you don't have any, but typically it's going to be 2 roots. Your roots are your x-intercepts. They're also called solutions, and they're also called zeros. So we have them here. I'm color coding in red at -2 and +2. Those x-intercepts, where this graph, the parabola, crosses the x-axis. We have a line of symmetry. And a line of symmetry is a line that makes the parabola symmetrical. So think of it as an invisible line that would cut it down in half. So I'm drawing that there in green. That's right down the middle. The maximum vertex is in gold. That we don't have one of those, but if the parabola were upside down, it's the highest point right there. But in this case, we have a minimum vertex because the parabola opens up. It points upwards. The U shape points upwards. The minimum vertex is right here where the vertex is. And that's at 0, -4. So I'm putting minimum vertex. So it might just be referred to as the vertex, or we'll call it more specifically a minimum vertex. Again, you only have 2 possibilities here. It's either a maximum or a minimum. So you got a 50-50 there. So the roots I did in red are at two locations on this parabola. That's negative 2, 0, and 2, 0. There's two of them. This parabola opens up because the U shape points up. You could draw little arrows up there if you wanted. That might be helpful. Points up. The vertex coordinates, it's also a minimum vertex, is at 0 and negative 4. The y-intercept is actually the same in this instance. Sometimes it's different, but in this case, the y-intercept is also at 0 and negative 4. It is a minimum vertex. When you see the words maximum or minimum, what it's asking you is to pick one of the two. Is the vertex at a minimum or a maximum point? In the axis of symmetry we did in green, it's going to be x equals 0. It's where is the vertical line, this vertical line that cuts the parabola in half. All right, let's look at some more examples here. So for this first one, we have a parabola. And so the question is, where is the vertex? I'll do that in blue. It's a minimum down here at 0 and negative 3. I just said it's a minimum. Apologies for the poor handwriting. There are two roots. I like to do the roots in red. They're right here and right here. Now, we're not exactly sure where those are, but we know that it's more than 1.5 and less than 2 on both instances. So I'm going to just call it at negative 1.75. And then the other one is positive 1.75 with 0 for both of those. Okay. The axis of symmetry is the line that would cut that right in half, right? And so in this case, x equals 0. Here's a little hint. The axis of symmetry is always going to be an x equals, and then whatever the x coordinate is from your vertex. So notice that these numbers will always be the same number. All right, number 2, moving along, just trying to keep this pretty quick, short and sweet. Vertex on this one is a maximum at 0, 2. So we finally have a maximum vertex. We have two roots again, one here. Looks at about negative 1.5 and positive 1.5, I'd say. And the axis of symmetry, again, cutting it right down the middle along the y-axis is x equals 0. Again, I want to state this number on the vertex and this number are always the same number. Moving on, if we had to make a table from this, it's really not too much work. So we don't have the graph. We don't know what the graph looks like. Now, you can and should use Desmos, and I highly encourage this. And you're going to do some of that this week. But to do it by hand from a table, all we're doing is substituting the value for x to find y. Right? So I'm substituting in the value negative 4. Could be because my question is, what does y equal when x is equal to negative 4? Let's plug that in. Negative 4 squared minus 9. I'm using this equation, by the way. So that's negative 4 squared minus 9. Negative 4 squared is positive 16, and 16 take away 9 is 7. Next one will be negative 3 squared minus 9. So again, substituting in the values for x right here. That's 9, and 9 take away 9 is 0. And so we would just continue with the pattern of substituting the values for x to find the value for y, right? And eventually you might be able to just use a Desmos calculator or your own phone calculator to kind of work through these faster. I'm doing some of this just kind of in my head. 3 squared minus 9, so here again we have 0. And 4 squared minus 9, again we have 7. I want to point out, notice that these two numbers are the same, and these two numbers are the same, and these. So these, you can almost picture the parabola. You can picture the U shape from the table. This must be the vertex. The vertex is the point at which it changes and starts repeating the same numbers. So let's graph that. If that was unclear, let me graph that. So the vertex is at 0 and negative 9. So I don't go left or right, I just go down 9. Right here, I put it in blue. Then on each side, at negative 1 and positive 1, it's negative 1 with 8 and positive 1 with negative 8. So here and here. Next points I'll do in red. 3 with 0 and negative 3 with 0. And then the fourth points, negative 4 and up 7, and positive 4 and up 7. So here's that U shape that I was talking about, where it kind of does like that. All right? So your roots, again, I did those in red. Your roots are your zeros. They call them zeros for this reason. Look where the zeros are for the y, or the f of x, the function. So we have negative 3 with 0 and 3 with 0. That's these, I'm going to make them bigger. That's these points in red, the roots. The y-intercept, in this case, is down here at 0, negative 10. That also happens to be the vertex. It's not, they're not, those two aren't always the same number, just sometimes. Because the blue, the vertex is at the bottom of the U shape, that makes it a minimum. This graph opens up. It opens up because the lines, the U shape is pointing up towards the top. And the axis of symmetry, if I were to cut this thing right down the middle, is at x equals 0. One more reminder that this number and this number on your vertex, the x-coordinate, are always the same number. And then last example of one of these, I want to fly through this because I don't want the video to be too awful long for you guys, but you can figure out, I'll just show you the first one. We're substituting this number in for x. So let me change colors just so you can see where I substitute that number. And in this case, I have to do it 2 times. See that negative 2 is what I'm subbing in for x. And I have to solve for y. Use your calculator. You can figure that one out. The numbers aren't too awful big. And so if I were to go through to continue substituting in the numbers, in this case it's negative 1, we get 0, 6, 8, 6, 0, and negative 10. Okay, so I fast forwarded, you would continue this process of substituting in whatever number they have for x right here. Okay, so you just continue that pattern. You're looking for the point at which two numbers change though. See, so like here's, you can kind of picture, here's going to be the vertex. Okay, and then on each side, 6s are the same number. And then here we have the zeros. And then here we have, again, same number. So this is what makes it a U shape. This is what makes it a parabola. So my vertex this time is right 1 and up 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then my next 2 points on each side, I have 0 with 6, so here, and 2 with 6, so right 2 and up 6. Then my zeros are at negative 1 and positive 3. See, I did those in red again. And then negative 2 and down 10. 1, 2, 3, 4, 5, 6, 7, 8. And 4, so right 4 and down 10. So your parabola this time opens down. Opens down, right? Points down. So you have the vertex here. You have 2 roots. And that's a maximum. Let me zoom out a little bit. So our roots are at negative 1, 0 and 3, 0. Our y-intercept is finally different this time than the vertex. The y-intercept is here. I'm doing a bigger green dot at 0, 6. The vertex I had in blue is at 1, 8. The whole parabola opens down. It points down, right? The U shape points down. And because it points down, that means the vertex is now a maximum because it's at the very top of the U. And the axis of symmetry is x equals, finally it's not 0, it's 1, because that would be where you cut this thing right in half. Just like that. Again, this number is always the same as that number. All right, moving on to domain and range. I'm going to wrap this up pretty quickly here. We're familiar with domain and range. Domain is the set of all your x values. And range is the set of y values. So domain is all your x's and range is all your y's. Now what's nice about this chapter for quadratics is that your domain, because we have, it continues infinitely, goes on forever in all these examples. See the arrows that I'm marking in red? When it continues on forever like that, this one we actually can't see, but it does. It does continue. They didn't put the arrows, but for this chapter, guys, it's going to be all real numbers, and you can indicate this two ways. Either you could write 3 words. You could write all real numbers. I'm going to just shorten up that, all real numbers. You could draw the symbol, which I always start by drawing kind of an 11, and then I make like an R out of it so that it looks like an IR or a TR. Or you could do it with the infinity sign. So negative infinity, x is literally between negative infinity and positive infinity. Okay, those are pretty terrible infinity signs, sorry. So I'm going to go through and do all those domains. The domain here is negative infinity to positive infinity, okay, or all real numbers. X just is going to continue. This parabola continues in both directions infinitely. So pretty easy for this chapter. Oh, negative infinity, x is less than infinity but greater than, is between the two infinities. It's just all the numbers. The y is the range is the one that you have to really look at the graph. Okay, so the set of y values in this example is, notice that the graph does not go below, I'm going to zoom way in, it never goes below this point, which is at 60. Let me erase that so you can see it. It never goes below 60. So what that means is y is, you can write this two ways. Either y is greater than or equal to negative 60, or you can put it between as like a compound inequality. Negative 60, you put the lower number on the left. It's greater than or equal to y, or y is less than infinity. Y can't be equal to infinity. Okay, so you're never going to have the equal to for an infinity. Let's look at this one. For the second one, notice that the graph, this U shape, I'm going to highlight it, it never goes above 2, right? No part of that graph goes above 2. So the range has to be any number less than or equal to 2. As a compound inequality, we would write that as y is between negative infinity and less than or equal to 2. Okay. Let me write the word or. You don't have to write this. You don't have to write both. You can pick one or the other. I just want you to know that it could be represented in those ways. 2 more and then we're done. For this graph, notice the graph does not go below 1. So that means that y is, and because it opens up, it's positive, right? It's above that number. Y is greater than or equal to 1. As a compound inequality, you can write that as 1. 1 is the lowest number that it could possibly be, and then it could go all the way up to infinity. And then last one, this graph does not go above, was that 4.5, right in the middle there, right? So it's all the numbers below 4.5. So y is a number less than or equal to 4.5. You can also write that as y is all the numbers to negative infinity between that and 4.5. Could be equal to that as well. And that's it for attributes of quadratic functions.